Yaskawa. You're watching the IEC 61131 Basics video tutorial series. This lesson is on arrays. Hi, I'm Matt Pelletier. What is an array, and how do you create an array in MotionWorks IEC? Do you like arrays? Everyone likes arrays. Okay, let's start. An array in IEC 61131 is a single variable that has multiple elements of the same data type. So in this picture you see here, there is an array, and there are multiple elements within the array. Additionally, each element is accessed through what we call the index in square brackets. They're numbered, usually starting with 0, up to however large the array is, and they use what's called an index. And so how do you use these in the software? You first have to create an array data type. You then create a new variable with this custom data type, and then you can access the data using the index and that variable. So we need to create our own data type, and to do that you'll right-click on the data types folder and choose Insert Data Types, and we'll give it a name. And a good practice here is to always prefix your data type worksheet names with some prefix for your company or for your project, something that, like in our case, we use YTTS, that's Yaskawa Technical Training Services, and this avoids the possibility of a naming conflict, because in the future you are very likely to want to use libraries and pull in projects together that use different data types, and you don't want to have the same name data type by using some common name. So now in our code, if you could follow along with me here, let's go to the data types folder. We have only one data type worksheet in here right now, so we'll right click on it to insert another data types worksheet, and we're going to call it YTTS underscore custom types. Now let's open it up, double click on it, and it looks a lot like a structured text program, but you can see in the edit wizard now there are not your normal groups. Instead we have array, string, and struct, and for this video we're using array. You drag that in there and you can see the syntax for defining this data type. We call this a derived data type because it is a customized data type derived from the standard IEC 61131 data types. So we have the important information here in the comments. We need to determine a type name, the array index, what are the index numbers, usually starting at 0 to however large you want the array, and then what is it an array of? Is it an array of words, of integers, of L-reals? You choose the data type here for the array. So let's create ours to look like this, where we have a YTTS train array. We'll have 8 elements from 0 to 7 of word. Okay, so let's delete the type name. We want to call it YTTS underscore train array. From and to, so we'll delete this comment. I want to go from index 0 dot dot is the syntax to index 7. You could use from 1 to 8. You could use from 3 to 27. It really doesn't matter. You're defining the size of the array right here and the index. Typically you'll use 0 or 1 as the beginning. And now I've deleted here the comment. We'll have an array of word. I somewhat arbitrarily chose word. Word as the data type. You could have any data type. And before you can use this data type, you do need to make to be sure that it is a valid definition. And I did get 0 errors. And then the next step is to now create a variable using this data type. So here I called it gTest variable. I think I'll instead call it g underscore my array. So let's go here to the global variables. And I'll keep myself organized here and put it under user variables. Insert, I right click there, insert g underscore my array. And now under type, if I type Y for YTTS, kind of small here, let me make that bigger, YTTS train array. There it is. And once I've compiled this, make it. And I think the first thing I'll do here now with this array for instructional purposes is let's monitor it. So I had a make, but I'll need to download those changes. Just to avoid making again, I went straight to download changes. All right, close that resource, go to debug mode, and I can right-click on it now to add it to the watch window. And here you can even see what this array looks like. Makes a little more sense, puts it in that format. And I'll click OK to add the whole thing. View the watch window. It's kind of small here. Let me make this bigger. So there it is, my array. And I can see all of the values. In this case, they're formatted for hex. Right now, they're all at 0. And the next thing I like to do is to use it in the code, just for a really simple example. We can use the main POU, and I'll go down here. This will have nothing to do with the operation of our application. I'm just going to use the AND function as an example, and I'll AND two elements of the array together and put the output into a third element. So I'll put the AND function. EN and ENO will be covered in a different video. Just you don't have to connect those. And so here's the syntax for using gMyArray is the name of my variable. So g underscore myArray. Since I would use a word data type, I can use an element of that, which is a word. I'll use element 0 arbitrarily and click OK here. I could also do this again, gMyArray with element 1. And let's output this to myArray element 2. So I'm just using these first three elements, 0, 1, and 2. And let's download that change. Okay, resource closed, debug on. And I can open up this array here again. And I could take this element 0 and give it some data. I can put it in decimal if I want. Let's do 3, 4, 5, 6. It overwrites. And we're ANDing it with 0, so the output's 0. I can double click this one. How about 5, 6, 7, 8? Converts it to hex there for the display. And you see we have an output. And so what this is doing is bit by bit, it's ANDing these together. If you recall, you could go to binary display, and this may make a little more sense for those of you guys who know about ANDing. Bitwise AND is happening here. And it looks like the only bit that has both ones is this bit here. And that's why it turned out to be what it was here in standard form of hexadecimal for this data type word. And for those of you who have used arrays, I think you're already aware of this. The idea is that with this array index, makes it very easy to, instead of using a number as I did, you can use a variable. So you can create an integer variable, perhaps starting at 0 for that 0 index, and then in a structured text code, makes it very simple to have some maybe calculations going on elsewhere that's updating variable 1, and you're loading an array, or maybe reading from or writing, in this case we're writing to the array pieces, the elements of the array, with the contents of this variable, and then when it's time to index to the next one, you can write your code to do that index, and you can end up filling a very large array with data. Maybe that data is temperature data or position data or anything related to your application can be stored this way, stored and read from the array. So arrays are very powerful and they're used all the time. I'd like to show one more thing as long as we're here using the word data type in the array, and that is the ability to use the dot notation to specify a byte or Boolean bit within the array. And it doesn't really have to even be an array. This is kind of an additional little tip here for you guys that has to do more with the data type of word, dword, and byte. So rather than talk about it, let me just show you real quick what I mean. For this example, I'm going to open the timers POU and come down to that timer sequence. And my idea is that instead of these variables timer 1 done, timer 2 done, timer 3 done, I would like to store these 3 bits into a word within my array. So all I need to do is replace this Boolean variable with my word element from the array. So I've got G, my array. I'll go over here and put in element, let's say I want to use element 0. And now watch this, I'll hit the dot key and it comes up. I can specify from any word data type, in this case it happens to be within an array, I can specify one of the bits. So I will use bit 0, that's x0. Click OK here. So I better copy this one over. I can Control C to copy so this still works. And then here this timer 2 will be G underscore my array square bracket 0 bit number 1. Bit number x1. Okay. We'll copy that, move it over to timer 2, and let's just do one more here. G my array element 0 bit x2, bit number 2. So now here in debug mode, let's just try this out. And I will reset it and turn it back on, create my pulse by turning this one on. Now here we can take a look at the array. Turned on byte 1. 5 seconds later, turns on another byte. 5 seconds later, turned on the 3rd bit, and it's just being displayed here in hex. And the other one here is ANDing it in the other POU. So again, this doesn't have to do so much with arrays as it does to do with the byte, word, and dword data type, but I just thought I'd show that little tip. Thank you.